We're on now to question 5. And question 5 has a nice easy start to it. We have a function f of x is equal to minus 6x cubed minus 7x squared plus 40x plus 21. Show that x plus 3 is a factor of f of x. Now, you could do long division here, or you could say if x plus 3 is a factor, then x equals minus 3 is a root, or minus 3 is the root. You sub in minus 3 as your input in place of x, and you show that that is equal to 0. And when the input gives you an output of 0, it is a root. Factorize f of x completely is part B. So in this case, most students are going to do long division. So start off, the first term divides into the first term. So x divides into minus 6x cubed minus 6x squared times. Minus 6x squared times x is minus 6x cubed. Minus 6x squared times 3 is the minus 18x squared. Line underneath, change your signs. So the minus will become a plus in both cases. The first part obviously must cancel out. That's the whole purpose of it. And then you're going to have minus 7x squared plus 18x squared gives you 11x squared. Bring down your 40x, bring down your 21. Well, some students will bring down their 21 at this point, and others won't. And either way, it works out the same. So now we look at the first term here dividing into the first term here. So x into 11x squared goes 11x times. We then multiply down, as you can see with the arrow. 11x times x is 11x squared. 11x times 3 is 33x squared, 33x. Line underneath, change the signs. The pluses become minuses in this case. The 11x squareds will cancel. You bring down your 40x minus 33x gives 7x. Bring down your 21. Things are looking good now because x into 7x goes 7 times. 7 times x is 7x. 7 times 3 is 21. Line underneath, change the signs. And hey presto, everything cancels. Remainder of 0, which again shows that x plus 3 is a factor of f of x, but also shows us that, well, if x plus 3 divides in evenly, x plus 3 is a factor, but so too is the quadratic on top. You could have also used the grid method, and some people will know this method of factorizing as well. And you could see you get the same answer. So some students like that because you get there a little bit quicker. We know so that the original cubic, which was f of x equals minus 6x cubed minus 7x squared plus 40x plus 21, has now factorized to a linear and a quadratic. I can factorize the quadratic to give me minus 3x plus 7 plus 2x plus 1 times 2x plus 1. So I'm now going to solve for x in both of these occasions. Well, actually, no, I'm asked to factorize completely. So there we go. I've done that for 10 marks. So certainly the first 15 marks there are relatively straightforward. And part C is, again, not too bad. Given that f of x equals 0, use your answer for part B to solve for f of x. So again, this is just continuing on now to solve. So we're going to get x equals minus 3. We're going to have x equals 7 over 3 and x equals minus a half. Now, we continue on from there, and using your answers from part C, you're going to solve the equation 6 times 2 to the power of 3y plus 7 times 2 to the power of 2y equals 40 times 2 to the power of y plus 21. And give your answer correct to 2 decimal places. So what's happening here? Well, it says, we can see our original equation here, and we can see that the coefficients and the constant are the same as what was in the original. So we have a clue on what we're to do here. And students would have seen questions somewhat like this before. So if we rearrange, so we say, well, we know if I said, if I had 2y to the power of 3, I know from my third law of indices, 1 power raised to another power means I can multiply those powers together. So I can work it the other way around as well. 2 to the power of 3y can be written as 2 to the power of y all to the power of 3. 2 to the power of 2y can be written as 2 to the power of y all to the power of 2. Then I can say, well, rearranging here, and what I'll have done here is, if you see this, basically I've kind of subtracted 6 times 2y to the power of 3 from both sides. I've subtracted 7 times 2 to the power of y to the power of 2 from both sides. So I would have 0 is equal to minus 6 times 2 to the power of y all to the power of 3 minus 7 times 2 to the power of y all to the power of 2 plus 40 times 2 to the power of y plus 21. And then I've just rearranged it here to have the 0 on the right-hand side. And now I can then say, well, let 2 to the power of y equals x. This is a trick we've seen before. And what I can say then is, like, I will have this equation. All right, so let 2 to the power of y equals x. So I'd have minus 6 x cubed minus 7 x squared plus 40x plus 21 equals 0. And of course, that's what I have up here at the very top. Now, we know from our previous answers that, for example, one second here now, we know that x equals 7 over 3 is actually going to be the only valid answer that we can continue on with from our previous part. And the reason is because when we have 2 to the power of y equals x, well, if we have 2 to the power of y equals 7 over 3, I can say, okay, I can get a value for that. So I can introduce logs. The base will remain the base. What was the power becomes the answer, and what was the answer becomes the power. So now I have y is equal to log 7 over 3 to the base 2. Okay, and I can solve for that. So typing that into the calculator, I can say the log of 7 over 3 to the base 2 is going to be equal to 1.2223. I want to correct it 2 decimal places, so I get an answer of 1.22 corrected 2 decimal places. Okay, that would be a valid answer. Now, let me continue here and look at it just a different way. If we went from here, if we went from y 2 to the power of y is equal to x, I can take the log of both sides. So in this case, I'm saying log, so that'll be log to the base 10, right? So let me just write in the base 10 as well for now. So log of 2 to the power of y all to the base 10 is equal to log of x to the base 10. I can use my power to the front law to say y times log 2 is equal to the log of x. And I can sub in my 7 over 3 and now divide both sides by the log of 2. And when I type this into the calculator, I'm going to get that same answer, 1.2223. Corrected 2 decimal places, I have y equals 1.22. Now that's 10 marks, and it is for part C and D combined. Now you could be wondering, you may well have tested some of the other possible answers from part C, but our last part says explain why x equals minus 3 does not lead to a valid answer for y. So, you know, if we have a negative answer here for x, why does that not lead to a valid solution? Well, again, if we go to x equals minus 3, and we know that 2 to the power of y is equal to x, then 2 to the power of y is equal to minus 3. However, there are no valid solutions for y in elements of real numbers, which makes this equation true. Again, if I use my key rule of logs, if I introduce logs, I say log minus 3 to the base 2 equals y. However, if you type that into the calculator, you're going to get an error because it says 2 to what power will give you negative 3. Same here, 2 to what power will give you negative 3, and there is no real answer for that. So that was the final 5 marks, and that brings question 5 to an end. So started off relatively easy, gets tough there in part D, and a bit of understanding needed to get that last 5 marks in part E. Okay, so we'll move on now to our final question in the skills part.